In this video, I'm going to show you how to generate an asymmetric public-private key pair using OpenSSL. Anyways, let's get started. So we're going to be generating an RSA key pair, meaning we're going to be generating a public key and a private key. Just a quick primer on asymmetric versus symmetric keys. For symmetric keys, both encryption and decryption are used by the same key. They're not really used as much as asymmetric keys. In an asymmetric key, everyone has the public key, so everyone can do encryption with the public key, but only certain users have the private key and can perform decryption. Asymmetric keys are what your browser uses to send data over SSL. Basically, everyone has the public key for the SSL certificate, so the browser encrypts with the public key and then sends it to the server. And then only the server can decrypt it because only the server has the private key. So no man in the middle would be able to decrypt it. But we're going to be using the OpenSSL library in order to generate these keys. If you don't have that library, you can just install it using Homebrew or Aptitude, depending on your operating system. But I think most operating systems are going to have OpenSSL, so I'm not going to cover that here. All right, so we're going to go ahead and generate the key. So I'm going to open my terminal here. And let's see where I am. Okay, let's do make directory, and I'm going to do SSL, actually RSA key pair, and then let's just go into that directory. Cool, so we have a nice little space that we can work in here, and we're going to supply this argument here, and this is going to generate the key pair, and it's going to generate a 2048-bit key. And that relates to the level of security of the key. It's a pretty common bit length. Enter passphrase for private.pm. So we're just going to add a code. I'm going to do apple123, and then we'll enter it again. And not every key pair has to have a code, but in this case we do. So now we have this private.pem, and we need to generate a public key from that. So let's go ahead and run the second command here, which is just going to export the public key. And I'm going to do apple123. And now we can see, okay, we have both the private and the public key. So I'm going to open this up in VS Code real quick. Just so you guys know what these keys look like, they're just hashes of text. But based on the way they're generated, the algorithm that's used to generate them, and the length of the key, that will dictate like the level of security. So again, this is a 2048, but you could have 4096. You can have really any length, but there are more standard lengths and that sort of thing. And the length will dictate how easy it is to brute force, to attack. So we have the private key and the public key. So basically, you would use the public key to encrypt data, and then you would send the data somewhere, but only authorized users who have the private key could do decryption. And that's where this differs from symmetric key, where you would use the same key for both encryption and decryption. And again, this is used for common protocols like SSH, Secure Shell, or HTTPS, which is sending data over TCP/IP. But that's how you generate a public-private key. Hope that is useful. Thanks. If you like this video, go ahead and hit that like button. Thanks for listening.